Yesterday I was asking you to do an MPLS lab and put those show commands and see what you get. I believe that you have done it. Now let us move on to the next level. What you have learned in MPLS so far is the actual MPLS. What you're going to learn in MPLS Advanced is MPLS with BGP, what it can provide us. So it is called as Advanced MPLS with BGP. MPLS with BGP. MPLS simply means multi-protocol label switching, right? Did you see the label switching happening? Yes. Which means the MPLS is over. Now we can have multiple layers of MPLS. That is what advanced MPLS. You can have multiple layers of MPLS. We did only one layer of MPLS. To provide another layer, we need BGP. If you don't like BGP, you still have multiple layers for which we need to create a GRE tunnel. Let's not focus on that. That is not the real use case. So we are going to form a tunnel using BGP, TCP connectivity between two PEs. We are going to form an IBGP with a remote router with which we are going to have a tunnel. MP-BGP can provide it. We call it as MP. We said MPLS, right? MPLS. We said MPLS. This is MP-BGP. Multi-protocol BGP. This multi-protocol label switching. So this BGP can work with multiple protocol including MPLS. MPLS is one of the protocol. See, already MPLS is multi-protocol. And when MPLS becomes one of the protocol in MP-BGP, MPLS is compatible with multiple protocols. The same MPLS is also now used by MP-BGP, which means this MP-BGP is compatible with all MP-BGP tunnel. Here MP-BGP says BGP not only forms an IBGP connection, it can form MPLS layer 3 VPN. It can allow you to form MPLS layer 2 VPN. It allows us to form VXLAN control plane called EVPN. It allows us to have segment routing and much more. That is what an MPLS. Okay, a simple example. It allows you to have IPv4 as well as IPv6. So that itself is two different layer 3 protocol. So that's the meaning of MP. What we are going to learn is MPLS layer 3 VPN. MPLS layer 3 VPN, which is MP-BGP. But MP-BGP is not. MP-BGP is not layer 3 VPN. Layer 3 VPN is one of the feature the MP-BGP supports. So sometime, instead of saying layer 3 VPN, I hear people saying MP-BGP, MP-BGP. What MP-BGP? He don't know what is MP-BGP. That's why he uses that word. MP-BGP means it includes a lot of things. VXLAN, segment routing, it's a EVPN, layer 3 VPN, layer 2 VPN. There are many more. When you say MP-BGP, it's a big umbrella. IPv6. So we should not use the word, MP-BGP, you should not use the word when you want to say IPv4 or VPN-v4 or layer 3 VPN. Better you say MPLS layer 3 VPN. That's the right word to use. But I myself started this class saying MP-BGP just to break that confusion that people have got. My intention is not to teach MP-BGP, my intention is to teach IPv4 layer 3 means IPv4 means layer 3 VPN. Layer 3 VPN. Layer 3 MPLS VPN. That is what our actual topic is. Or you can simply say layer 3 VPN. But there are a lot of layer 3 VPNs, so better put MPLS. So instead of putting MPLS, they say layer 3 VPN, layer 3 VPN. Sometimes they say MP-BGP, MP-BGP. Confusing terms. And someone says MP-BGP, for me it means EVPN. Sometimes it means layer 3 VPN. Sometimes it means IPv4 session, IPv6 BGP session. Sometimes they say layer 3 VPN. Which VPN? What VPN you're talking about? Are you talking about GRE? GRE is also layer 3 VPN. So say layer 3 MPLS VPN. That's the right word to use. It is one of MP-BGP feature. So we'll cut this off. Our topic is MPLS layer 3 VPN. Now this MPLS can provide labels, we know. It can provide labels. So we got some routers here inside an autonomous system. And between these two P1 router and PE2 router, we got MPLS everywhere. So MPLS is running, all these red lines are MPLS. Okay, by the way, I want to ask you a question to check whether you did lab yesterday. Can we enable MPLS on a loopback interface? It is not even possible. If you try giving, it will show error. No, it won't accept the command. Try to put the command MPLS IP on a loopback interface, it won't accept you. Why? We cannot have any label distribution through the loopback interface. It's not a physical interface, it's a virtual interface. So others have not even tried the lab, correct? They have not tried the lab. Mhm. Okay. So we are going to have a tunnel now between this PE1 and PE2 to provide that service. This is going to be used as a transport MPLS. Listen, the MPLS that we run between these routers, P1, router 2, router 3, router 4, P2, the MPLS that is running in between is going to contribute in forming layer 3 VPN, layer 3 MPLS VPN, one of the MP-BGP feature. Sometimes people say MP-BGP tunnel. Okay, you can say that MP-BGP is what provides this tunnel, but in MP-BGP, which one? Layer 3 MPLS VPN feature. So, why it is MPLS? Is it not BGP providing this tunnel? Yeah, absolutely, BGP is providing the tunnel. But who is using the tunnel? MPLS. If not, the tunnel cannot be used. Only MPLS can provide label through the tunnel. So now, already we know that there is a label distributed between this router. Labels are used, and you saw me doing the lab. Now, there is another label given inside and this label is for whom? This label is for all the customer routes. A wants to ping B. For A networks, label is advertised through the tunnel, inside the tunnel. A network and B network will not be seen in any of this inside router. A network and B network are customers' networks. There is no need for the inside core router to know about it. So an A and B advertises this network to the P router. P router advertises this network using BGP along with label, so that when someone pings B, PE1 can put a label and send it to R2, sorry, PE2. And PE2, just by looking into the label, it will know that I need to send to customer B. We call it as service label. This labels that you use in every hop is a transport label. In order to transport between PE1 and PE2, in order to transport this tunnel traffic, transport labels are used. When customer A wants to go to customer B, packet comes to PE1. Packet comes to PE1. Now this PE1 will encapsulate with a label, one inner label, service label, let's say 27. The 27 is for the network B, customer B network, slash another layer of MPLS to move the packet from here to here, let's say 18. So with the help of 18, the transport layer label, it comes to router 2. Router 2 will remove the label 18, maybe it will put label number 30 provided by router 3, and it sends to router 3. Router 3 will change this label and put the label given by router 4. Let's say that is 19. And then the packet goes to router 4. And router 4 will do PHP. You know what is PHP? Router 4 will do PHP and send only this 27. When it goes here, this router knows what 27 means. 27 is the label given for all the networks of customer B. So it delivers the traffic out via the interface where customer B is connected. You see, we got two layers of MPLS. One for switching the packet locally till it reaches the other PE router. We call it as transport label. The other one will not change till it reaches the final destination, which is service label that identifies the customer to whom this packet belonged to. See, there may be many customers connected here, like B, there may be C. For each customer, there will be one label given, repeating again. For each customer, there is going to be one label. So, we got a service label, we got a transport label. Who provides the label? MPLS. Who provides the tunnel? BGP. The 27 label will not be known to any of this inside router. Router 2, router 3, router 4 has got no idea about BGP. We don't run BGP on router 2, 3 and 4. We don't run. BGP is running only on the PE routers. Only PE routers will learn all the customers' route. And tunnel is only between the PE router. So now the tunnel will provide a label to identify the customer route. Using the label, the encapsulation happens and goes to the other end, delivers. This is what called as layer 3 VPN. But this is not a complete story. This is the MP-BGP part of MPLS layer 3 VPN. What we have seen is, we have seen that we can have a VPN for which BGP, IBGP is needed. So between PE1 and PE2 we got IBGP. We negotiate and form IBGP. Not only that, we also negotiate and form VPNv4 tunnel, which is also called as MPLS layer 3 VPN tunnel, VPNv4 tunnel, VPNv4. We negotiate VPNv4 under BGP, which is what we call as MPLS layer 3 VPN. Through this tunnel, MPLS labels for the customer will be shared. Using that label, one customer will use to reach the other customer over this transport tunnel, over the service tunnel. The other part of the story is this. Now, internally, we have some networks. Customer service provider has got some networks internally. And then the C customer advertises some network. B customer advertises some other network. Likewise, D advertises some other network. A advertises them. So these networks coming from different customers need to be handled separately, for which we need to create virtual routers inside this physical router. So on this PE router, I need one routing table for the provider network, and I need another routing table. It's not a physical router, it's a virtual router I'm drawing, where all the customer A routes will come and stay. We call this type of virtual router as VRF, virtual routing and forwarding. For each customer, you need to create one VRF. So in PE1, if you ask me how many routing tables we see, there will be two routing tables. One, the default global routing table that will not have any customer route, it will have only ISP's route. The other one is the customer's route routing table, which is VRF table. So how many routing table will PE2 have? PE2 will have totally 4 routing tables. One is the default routing table for the provider network, and 3 VRF routing table for each customer. When we talk about VRF, to identify VRF, we have route distinguisher. VRF for each customer will provide one VRF. For each customer, one VRF. Like a VLAN number. VLAN number, you don't know. What is VLAN? Virtual LAN. This is also same like VLAN, but this is not a LAN, this is WAN, virtual router. Like you have VLAN 100 to differentiate traffic of VLAN 200, right? VLAN 100, VLAN 200. What is that 100 and 200 doing there? It differentiates the customers, VLAN traffic. Likewise, route distinguisher differentiates. Route distinguisher differentiates customers. For each VRF, there will be separate route distinguisher. Route distinguisher is 64-bit value. 64-bit value. 32-bit colon 32-bit. Route distinguisher 64-bit value. It can be anything. You can assign anything. In a router, you should not use same route distinguisher for different VRF. Repeating again, in a router, you should not have the same. You should not have, like, say for example, 1:1. You should not give this 1:1 for any other VRF on that route. You may have the same route distinguisher on the remote router that does okay for the same customer or for the different customer. You can have same route distinguishers. Okay, they won't. They are locally significant. Route distinguisher is locally significant. So each VRF will have a route distinguisher. See, as the word says, distinguishing route. Right. So next is route target. This route target is also another 64-bit value. But this is very unique one. Don't compare this to VLAN. See, VLAN is globally significant. VLAN is not only on the access port, even on the trunk port, same meaning. Whereas here on the layer 3 VPN, route targets are to differentiate the customer route over the tunnel. Our tunnel is like what? A trunk link, right? Tunnel is like a trunk link. Inside the tunnel, to differentiate the traffic, you need route target. See, the word says target. Target means what? Where to go. Where to go. The destination. To whom this belong to, this route belong to. See, that's why it is target. To whom it belong to. Where it belongs. So we got route distinguisher and we got route target. Route distinguisher is locally significant. It can be same on the other PE router, it can be different, that doesn't matter. But route targets should be matching on either side so that whatever this sends can be received from the other side. This route target is again, export and import. We'll talk about that in detail when we do the lab. But what I'm coming to say is it should match. But route distinguisher need not to match. Route target need to match. So this is the confusing place for many. I don't think you are confused because I made it very clear. I took a lot of time for this. Route distinguisher is to differentiate the routing table. I also said it is locally significant. What does it mean? That need not to be same on the other PE router. If you keep it same, nothing wrong. Route target, what I said, it helps to take an update from PE1 to PE2. But in PE2, there are many customers. To which customer this belongs to is determined by the route target value. So that should match. Route target, if you have gone in aeroplane sometime in your past, route target is like what to say, the label that is attached to your baggage. Route distinguisher is like the seat number in the flight. See, you and your luggage travels in the same flight. You have a seat number which is locally significant. The seat number is locally significant. That seat number doesn't matter when you land there. They don't want to know what seat you are sitting, which seat you are traveling. They want to see whether this baggage belongs to you or not. They need only your baggage tag. It's right behind your ticket, the boarding pass. Flip the boarding pass, you will have a sticker there. That sticker should match with the baggage sticker. What you have behind the ticket is the export value. What you have on the baggage is the import value. If this export tag and import tag matches, then the box belongs to you. If not, they don't give you. That's route target. So whatever we have spoken now is one part that we should really clearly know in order to successfully do layer 3 VPN. The other part of layer 3 VPN is routing related. Whether to redistribute or whether to advertise, those things we'll do it clearly under the VRF BGP address family. When we do the lab, I'll explain and do it. I don't know how much level you understood today's class, but you have to listen to this video till you get something so that when I do a demo and teach you this, it will be a complete learning. Unless you see me doing this, it won't be a complete learning. For those who have listened to this class, it looks like, okay, something is there. Something I understand. That is what I want. Something I understand. If you say, no, nothing I understood, then you did not listen carefully. Something I understood, but still it's not clear, then you are a good listener. When you listen to the configuration part with explanation in next class, you will get the complete knowledge. But if you miss to understand today's class, tomorrow's class will be like simply typing commands for you. He was typing too many commands. It was very difficult for me. That is the feeling you will get if you don't understand today's class. If you understand today's class and listen to tomorrow's demo, you won't feel like we are typing too many commands because you will know the reason why we type those commands. And you will know, okay, these commands need to be there. So when I type, you will know, okay, oh, this is why he is typing this command. Okay, we need to send the route target through BGP. That's why we need to use this command. So go through this video till you get something. Same like what you did yesterday, homework, no? You also do this homework. And come, and tomorrow we'll have a demo of this. If you have any question, you may ask now. Correct. Any other question? என்ன தலைவர் இப்போ எவ்வளவோ எக்ஸ்பிளனேஷன் கொடுத்து இப்படி சொல்றீங்க? நான் உங்களுக்கு தெளிவா சொன்னேன் இல்லையா, இது வந்து I clearly said route distinguisher is like a seat number. RT is like the baggage sticker. You need both for traveling. And I also said RD is to differentiate the routing table locally on the router, whereas RT is to differentiate customer routes over the VPN tunnel. Now what is the confusion? Tell me. Over the tunnel using BGP. BGP will send it as an update. BGP is forming neighbor, no, between two PEs. So between two PEs, it will come as an advertisement. Yeah, correct. LDP is what going to provide label that BGP should carry. Correct. Welcome. Yes. On top of that, we will also form VPN neighbor, another BGP neighbor. In between routers, no need of BGP. Why? Because we are going to form VPN between only PE1 and PE2. We very well know that IBGP need not to be directly connected. Right? Any other question? Fine then.